section 1.7 is called solving equations and solving problems. So we're going to look at some equations, and these are very similar to what we just saw in the review flipbook, right? So we're going to write an equation like 5 times 2z minus 9, set it equal to 7z minus 60. And we've got a set of parentheses, so that indicates to us that we need to use the what property? Distributive, right? So we're going to distribute here and here. 5 times 2z is 10z, and 5 times negative 9 is negative 45. I almost wrote 49, 45. And that's going to be equal to 7z minus 60. Then you notice, oh, we have variables on both sides, so we can either move them both to the left or both to the right. I prefer mine on the left, so I'm going to subtract 7z from both sides. In the same step, I'm going to add 45 to both sides. If you'd like to show that as 2 separate steps, you can, okay? These guys are opposites, they cancel. These are opposites, they cancel. And then we have 10z minus 7z, which is 3z, and negative 60 plus 45, which is negative 15. And then the last step, we're just going to divide both sides by 3, and we get z is equal to negative 5. And most of the time, your answers are going to turn out just like this. It's wonderful. That is called the solution. Every once in a while, you won't get this nice, pretty solution. You'll get something weird. And your answers can be what we're going to call more than one answer. Or maybe you'll get no solution. Or maybe you'll get all real solutions. So something strange is going to happen. And it's going to feel like, oh, I need to do the problem over again. I did something wrong. And so you might want to check it, but then you might realize, no, I did it right. I just got this weird answer. Okay? So example number 2. We're going to have 3 times 2s minus 3 equal to 6 times s plus 1 minus 10. Bless you. And just like example number 1, we've got sets of parentheses, so we need to distribute both sides of the equal sign. 3 times 2s is 6s. 3 times negative 3 is negative 9. That's our left side. On the right, 6 times s is 6s, and 6 times 1 is 6 minus 10. So we can simplify on the right, right? What's 6 minus 10? Negative 4. So we have 6s minus 4, and over here we have 6s minus 9. And again, we have variables on both sides. But is anybody seeing anything strange? They're both 6s. So if we go to subtract 6s minus 6s, these cancel as well. So we end up with negative 9 equals negative 4. And it feels like you did something wrong, right? So double check it. Yeah, I did that right. Yeah, I did that right. And then go, okay, this one's weird. Does negative 9 equal negative 4? No. So if you get something weird like that, you're going to say no solution. Some books or some teachers might call it the empty set. I've even heard the word null, spelled N-U-L-L. I've even seen it called false. So there's like more names for it than there are steps to solve the problem. You can write any of those, whichever you feel most comfortable with, okay? Example number 3. All right, so for example number 3, we have 3 times 2x minus 3 equal to 6 times the quantity x plus 1 minus 15 more. So again, double sets of parentheses. We've got some distributing to do and some simplifying. So 3 times 2x is 6x. 3 times negative 3 is negative 9. Over here we have 6 times x, which is 6x, and 6 times 1, which is 6, and then a minus 15 more. And again, you can already see the problem starting to arise. But let's simplify. 6 minus 15 is what? Minus 9. So we have 6x minus 9 over here, and we have 6x minus 9 over here. So if we subtract 6x from both sides, and we add 9 to both sides, these are opposite, these are opposite, these are opposite, these are opposite. Are we left with anything? We are left with 0 equals 0. This is one of those weird ones. So kind of look at it and go, did I do it right? Yeah, I did it right. Because it's going to feel awkward. You're going to be like, I totally messed this up. But you didn't. The answer is actually all real solutions. Some books call it an identity. And then sometimes they say it's true. Those are all words that I've seen used to describe it. Okay? Most of your assignment are problems like this. Then you get to a set of problems that look like example number 4. And example number 4, we have a ton of variables. We have S, we have G, we have T, we have V, and T again. And so next to the problem, it'll say something like, solve for V as in Victor. Solve for V. If you have a highlighter, the best thing to do is to highlight that V, because that's what you want to get by itself. So you're going to do a bunch of inverse operations, but your final answer is still going to have a bunch of variables in it. And just like these 2 other problems, it's going to feel like it's wrong, but as long as you get V by itself, you are going to do it correctly. So the first thing I want to do is move this term over to this side. So I'm going to subtract it. I'm going to subtract that VT. And it's the only term I want over there, so I'm going to subtract the S in the same step. That leaves me with just the negative VT. So I have negative VT equals the negative 1/2 GT squared minus S, because these 2 cancel. Then I notice that everything's negative. So I'm going to do this weird thing next where I multiply everything by -1, just to make everything positive, because I like to deal in the positive. So VT equals positive 1/2 GT squared plus S. And then the last step, because I'm solving for V, is to do the inverse operation of multiplying by T. So I'm going to divide by T. I'm going to divide this by T. And notice I already have a T squared there. And I'm going to divide this term by T. So here they cancel. And we're left with V. So we're almost done. When you get down to whatever variable you're solving for, you're almost done. T goes into T squared just T times. So you're left with 1/2 G T to the first. And then S over T, nothing cancels, so just write S over T.